Great, thanks so much. I want to start out actually acknowledging land, specifically the land on which I conducted my work and the land here at Cloquet Forestry as occupying ancestral, traditional, and contemporary lands of the Anishinaabe peoples. Here in particular, we are on lands of the Fond du Lac Band of Lake Superior, Chippewa, and these lands were ceded in 1854 and 1855. And that stewardship has really, in many ways, made the work I do possible in terms of stewarding these lands to where they are today. I am what's keeping you from going home, so I apologize for that. I think I might be the only non-forest talk too, although maybe these lowland brushes are sort of in between. Before I get started, I want to acknowledge other folks involved in this project. Lindsay, who's in the room here, Charlotte, who I think is online, Lee Freilich, who is not with us today, as well as a couple of grad students, Amy Hawkinson and Lori Knossela, an amazing field crew, and also the management staff that actually conducted the burns and made the work possible and helped us get to some of the more difficult to reach areas of our sites. Brushlands. Any of you ever spent much time in brushlands? Wow, did I not expect brushlands to be what they were. Brushlands are pretty amazing, but they are not easy places to get around. They consist of these open kind of sedge, grass-dominated kind of meadows, interspersed with shrubs. Mostly willows that can become rather tall, and there's a person in this picture if you can't see them. So they are really a heterogeneous mix of these where you have areas of shrubs, tall, short, open areas, and these are open landscapes that are really important for wildlife. And that was the interest of this project, was understanding disturbance and management of these from the focus of keeping them open and fostering wildlife. So birds, these are home to many, many different species of birds, breed here, use these habitats. They're also important for fur bearers. And we saw lots of really cool, interesting insects out within our plots in the course of our study. One of the challenges with these is that without disturbance, or just fire-dependent systems, without disturbance, this becomes what they look like everywhere. And so one of the main goals of management of these systems is really keeping these dense, tall shrubs at bay, maintaining this open habitat to support diverse wildlife. This is done in a couple of ways. Most commonly prescribed burning in the spring, and also shearing and mowing, which opens up broader range of seasons in which to work. That's an important point because in the past, the disturbance occurred in all seasons in these systems except winter. And so the project goal, or the key question when we came into this project when we were funded to work on, was asking, might summer and fall burns be more effective at meeting the goals for brushland management, for keeping those shrubs at bay. And we focused in our assessment of that on breeding songbirds and on vegetation responses. I'm going to give you the take-home right at the start, and then I'm going to try and back up that take-home, show you data to back up that take-home. So the first answer in terms of that question of might these different seasons be important is that yes, they're important. And one of the take-homes is that to benefit the most different species of breeding birds, incorporating summer and fall burns into the disturbance regime can help facilitate that goal. Oh, look, my emojis aren't working. Why? We don't know a ton of the mechanisms behind this because this is, at this point, we have observational data, but we have some ideas why. First off, burning in different seasons promotes a real range of different patches that vary in height and vary in how rapidly they seem to be kind of resprouting and coming back. And different types of birds prefer different areas of these brushlands. So you have birds that tend to occur largely where there's lots of tall shrubs, things that occur more commonly in the grassy areas, and those in between. And so burning that supports more diverse, heterogeneous vegetation there will support more diverse set of birds. Okay, so what did we do to come to these conclusions or take-homes? We had 4 study sites. Actually, we started with 5, but one of them got dropped. 4 different brushland areas, a mix of WMAs and actually some private lands. Each site we broke up into 4 different units, a no burn control, and then the 3 different seasons of burns. These were about 100-acre units, which is why we focused on songbirds and not other birds that had no would be using all of the areas. Not me, but amazing team from the management organizations were able to conduct 10 successful burns at these sites. So we ended up with burns at 4 sites and multiple seasons at each site. So I feel like we were really successful in this regard. We conducted vegetation surveys and burn surveys, largely looking at top kill as a way to look at how severe were these fires, as well as avian point counts. So what did we find that led to those conclusions I started with? Well, first some just general overviews. First, we found over the course of and this is 3 years, we have of avian point counts. We found 105 different bird species. 26 of them are on the Minnesota Species of Greatest Conservation Need. 21 of them fall in the Lake States Fire Science Consortium's fire dependent species. Many, many species of willows, a couple of threatened species, a number of first records for some of these counties. We were worried about invasive species. We didn't find very many out there, although there were some. The common yellowthroat was the most common bird we found, as well as the sedge wren. So these were the birds that were kind of ubiquitous throughout these different sites. Other notable birds were golden-winged warblers and LeConte sparrows. Everyone got very excited when they heard LeContes. I'm not a birder, so I didn't quite appreciate that excitement, but I thought I'd share it for those birders in the room. So in terms of burn severity, looking at how effective were these burns, one of the things that was pretty common is that less area was burned in our summer fires. So while but the areas that did burn across in all 3 seasons had similar levels of severity. So where we got burns in the summer units, they had like 90% top kill, but less of the area burned in summer. All right, what about the vegetation? So I'm going to give you the take home and then show you the data. The vegetation take home is really that spring and fall burns reduce those tall shrubs more than summer. They're quite effective at that, but they really stimulate resprouting. I'm going to show several of these, so I'm going to slowly walk through it because this is my busy slide for people, and I tried to put some landmarks to help. These are size classes, so we've measured shrubs in height classes from the smallest to the largest. This is how much they changed in density from before fire to after. So if you're above the line, there's more stems after the burn. If you're below the line, there's less stems after the burn. And I've circled that 1 to 2 meter height class, which were the ones that were most affected by these burns. And you can see that the fall and the spring, that's these different panels, has the most reduction in that. And there was reduction in the summer, but less so. This is all plots together, so those that burned and those that did not burn. These patterns are more pronounced in burned-only plots. So this is basically the same graph, but only taking plots where fire went through, and we see large reductions in these taller shrub classes for all 3 seasons. The next point, getting to this resprouting, these are the smallest size classes, so it's the same kind of graph. Above the line, more stems after burn, below the line, less stems after burn. And what we see in both fall and spring is that we see a lot of resprouting. So we burned the site, we've reduced these tall shrubs, so we're getting lots of resprouting. And in contrast, in the summer burns, we're not seeing that resprouting response. This is more pronounced when you only look at the burn plots. So again, these are the burn plots. And my hand-waving hypothesis here is that, dormant season, they have reserves, meaning when you come out of the dormant season, you can use those reserves to sprout. When you're not in the dormant season, you have less of those reserves, and so less of a resprouting ability. Wildlife. So wildlife take home, or the bird take home, is that burning increased bird abundance overall, and that species responses to burns were really diverse. There was no uniform response, which isn't surprising given that the burns are changing the vegetation and the different bird species respond to different aspects of the vegetation. So this is similar to those graphs of the vegetation. Here we have all 4 of the seasons on them, the unburned and the different seasons. This is change in total abundance, and this dotted line is kind of where the control is. So if you're different from the control, we're seeing a response. And again, above the line means more birds after the burn, below the line less birds after the burn. And we see that across the board, there are more birds after burning, and that these red ones are ones that would, in the models we ran, were significantly different than the controls. In terms of individual species, I'm just going to show a couple of examples. This is a chestnut-sided warbler, and this is a bird that appears to increase after burns across all the burns, with stronger responses in the spring and the fall than in the summer burns. I contrast this with the swamp sparrow, which shows reduction in abundance after spring burns. So this is one of the birds that showed a response, but only to one of the treatments. And then here's the veery, which also showed a kind of less birds after burns, but in this case it was after the summer burns. So this is just a kind of a highlights of some of the individual species responses, illustrating this kind of diverse response of that community. And so to kind of close things up, I kind of want to revise that key question we went into this with, and state it more as what are the benefits of adding burns in different seasons to brushland management. And this table is, the goal was kind of to summarize across these responses, where spring we had the most area burned with similar severity. We had high reduction of shrubs, but high resprouting. In contrast, in summer we had least, but where it burned it was similar. We had moderate reduction of shrubs, but low resprouting. And then fall was somewhat similar to the spring. And so these burns are leading to some different outcomes in terms of vegetation that then I think play into the response of the wildlife communities there. And my kind of take-home message at this point is that to me it seems like to benefit the most species of birds, having diverse fire regimes, diverse management approaches will do that. I'll quote in a huge caveat, maybe not huge caveat, but these are all responses from the first year after burns. We are poised to potentially to get funding, and I never say we got it until we really got it, from the Environment and Natural Resources Trust Fund to do a phase 2 so that we can follow a 3-year and 5-year post-burn of vegetation and the bird community to really see how transient are these responses, and use that to further inform decision-making about management regimes for these brushlands. So thank you. I probably went over, right? Because didn't I start early?
No.
Does that mean I have 1 minute for questions?
You've got, can you see the time down there?
No, I don't.
No, right here, Rebecca.
Oh,
Yeah,
oh,
you've
I'm
got-
like 4.5 minutes.
Yeah,
So, yeah, thanks.
I got a question or a comment there. This isn't necessarily a vegetation benefit, but summer and especially fall burning, being able to burn then and avoid the nesting season, may be a significant benefit.
So I sort of laugh because I'm up here talking about birds and brushlands, and I'm a forest ecologist. But
Rebecca, can you repeat the
Oh,
question?
yeah, thank you. The question was issues associated with spring burning and nesting season, and the benefit of summer and fall burns is outside of the nesting season. And my answer is just laughing that I'm talking about birds and I'm a forest ecologist. So Lindsay, if you feel like you want to jump in here, my understanding from my colleagues who are the bird and wildlife specialists is that the benefits of the burning in general outweigh any losses in terms of nests. And that many birds will re-nest if they have already nested during that time. But certainly if that's a concern, yeah, if not burning when they're on nest reduces those losses. I guess the thought is that burning is important for these ecosystems in general, and that the benefits outweigh. That said, in terms of our general top kill, in the places that did burn in the summer, it burned like, we had like an 80% top kill. And so we weren't seeing resprouting despite that. There's some of the details of like, we didn't see as much change in the summer, and one of the things we've been trying to dig into is getting a sense for pre and post, like start, whether or not the fire preferentially went in areas that actually didn't have a lot of shrubs, which our on the ground observation was that in summer what burned was the areas that had the more grassy, sedgy areas, and that they would run into the like raspberry or willows, and the fire would kind of peter out. I would say there's some challenges there. If you could figure out how to get the whole area to burn, I think that the outcomes in terms of stem mortality would be similar.
All right.
Drive safely.
Yeah, Rebecca, thank you.